Welcome back. Today we're doing the day job, doing commissioned work and doing a few stainless steel boxes like this one. And what I hope to show you is how to do nice tight welds and also how to keep that completely squeaky clean. So I'm doing this with a brand new welding machine, so let's take a look at it.
So today's a fairly well-known company called Jasic. I've not worked with Jasic before, so I hope they know what they're getting into, because I will be finding what's wrong with it. So you may be interested to know that I have zero affiliation with Jasic. There are zero affiliate links. I can only link you to their website if you're interested. They've just given me the machine to review, and I don't need this machine, so I can guarantee it's going to be non-biased. So if this is any good and value to anyone out there, then I'll offer it to you for just $5. So what that is a raffle competition approved by YouTube. It's completely legit, and you can see all the contestants who have won previously. There should be a link in the corner here, or there'll be a link in the description for you if you're interested. Let's open it up and crack on, shall we? Try and keep it all looking nice for whoever receives it. So my first impressions are, I'm quite impressed. It seems very robust. Jasic were very clever as well not to put a plug on the cable. So although you can install a normal 13 amp plug that we use in the UK, these have little built-in fuses for those that don't know. These will only take about a 3000 watt draw before they start popping. So for a British household, you really want to get one of these blue plugs. This one's rated to 32 amps and I use it on the induction machine. But I think I'll try a normal plug for now and see how well it copes. And it also says that it does 110 volt power, suitable for any job site. Also, if we take a look at the earth clamp, we've got the proper big industrial connectors. It says it's a KDP50, rated to 315 amps. Now compare this to your standard hobby Chinese welder, and you can see that this is more rated for industrial applications. Something I was also surprised to find is a proper Parker branded welding torch. It says it's an SGT26. It also came with a tungsten, which was nice. I actually like Parker. I use these quite a lot with some of the industries I've worked with previously. In fact, my industrial MIG torch is also Parker, and I've had this for years now. So before we turn this on though, let's just have a quick nosy what's inside. Where'd that go? Ah, you idiot. Ah, there it is. So I've taken off both sides of this machine, and fascinatingly, the panels have a breakdown on all the components. So if a board or something gets broken, we can actually replace it. See, it's on both sides as well. This is a wiring diagram. That's really good news, because we must be able to maintain these machines and replace anything that goes wrong. This is the first time, however, that I've seen hot glue be used to protect some of the connections here. Normally you have just like a fiberglass panel that goes across. That's still susceptible to dust, so I guess this is a much better option. Now I don't really want to take the panels out to look at the controllers, so instead I've got a special inspection camera to show you. So I didn't intend to use it for this video, but I have the new Ulefone Armour 18T. This has thermal vision, but it also has the most amazing little attachments. This is called an endoscope. You can see I can control it here just using this little mechanism. So this is a good opportunity to see what it's like inside this machine. I'll put the screen up somewhere for you to see. Let's have a little look what's inside. So that looks like a power transformer there. If we look up, we've got some of the ferrite rings with induction coils. So that's a ferrite ring on the ground return. That's to stop high frequency coming back. Can I do a 360? Yeah, I can do a 360. So that plastic panel's stopping me from seeing the good stuff. Let's have a look down here. There's the large capacitors. Go deep diving in. Yeah, that's what I want to see, the RGBTs. I can't actually move around. That's the fan at the back though. Can't actually get a good look at them. They're there though. There's ferrite rings everywhere. Well, that was interesting. Now, I've been using this for a while and it is amazing. 108 megapixel camera, and it has a built-in microscope, but we can also get a proper attachment microscope as well. I'll do a review on the thermal imaging on this when we continue with the gasifier project. And for the gas line, they've supplied a quick connector. And as most of you guys know, I like to use pneumatic fittings with all the push-in connectors. All right, switching her on. Kind of like revved up then, that was interesting. So the first screen we're seeing, it says AC welding current. So that's for welding aluminium. We can go between 200 amps and 20 amps max, and we can change the frequency and the cleaning action down here. Press home, see what other things we've got. So AC TIG, TIG stands for tungsten inert gas if you don't know already. DC TIG, direct current, that's for stainless steels and normal steels, that's what we're going to be using. Mixed TIG, I don't think I've seen a mixed TIG before. MMA, stick welding. All inverter welders can do stick welding as well. System settings. And we've got user guide. Click that. Interesting. We've got full-on colour instructions here. It's even giving tips on arc angle and everything. Right, so beginner friendly. That's nice. Components. Right, so it's telling you what parts need to go with what. It's even given you the part number. So if we need a certain type of nozzle or component, I'm guessing you just tell that number to Jasic and they send it to you. System settings. Engineer mode. Turn on wireless control pairing. I'll do that for the foot pedal in a minute. Even change the language. How about that? So far you have to be English or Chinese. What is mixed TIG? Right, if we go on function settings, we can change a whole load of things. If you don't know what these symbols mean, this first one, for example, is 2T or 4T settings. That's how you want your trigger finger to work. We've got the wave selection, so you can go square wave, triangular wave, or pure sine wave, I guess. Arc striking mode, this was something I was interested in. Either high frequency arc or lift TIG. It's my understanding that a lot of pipe welders prefer lift TIG if you're a traditional kind. You can choose between either air cooling or water cooling. So that must be what that little grey plug on the back is for. You can plug in a water cooler for a water-cooled TIG torch. Alright, for what I'm doing though, we want DC TIG. Ooh, you can go down as low as 5 amps on DC TIG. Wow, we can be very precise with that. Parameter settings. So if you're not familiar with TIG, most of this might be over your head. Let me briefly explain the settings that I have. So for tacking up, I've got a pre-flow time, that's the gas shielding to start with, of 1 second. Then we've got the initial current, this is the strength of the arc from the get-go. I've got 0 upslope, so I'm not wanting it to go up to any other current. Peak current, I've also got it to 25 amps. I've got 0 downslope, so I don't want it to drop down to a certain amperage. And very lastly, if we go right at the back, we've got post-flow. The moment that's on 3 seconds, I'm going to actually upgrade that to 5 seconds. And that's basically holding gas over the tack as I'm doing it. Now, lastly, I've actually saved some settings. So going to storage. So on my settings number 1, click on load. So again, on the parameters, I've got a 1 second pre-flow. And now I've got initial current just 5 amps. It's going to take half a second to upslope into 15 amps. And now we've got background current of 35 amps. Basically, what that means, if I go right to the end here, I've got duty and pulse cycles. So with a frequency of 3 Hertz and a balance of 50%, and what that means is it's going to switch between 15 amps and 35 amps at 3 Hertz in an equal measure. These are the pulse settings and makes welding thin stainless steel really quick. So let's start fabricating and I'll show you how this all works. So then my components arrive at my door like this. This is laser cut 1mm thick 304 stainless steel, and it's got this protective film on this side because it's a mirror polish. But what I need to do now is to form and bend these up. Now, using my regular folding machine, I was able to bend the edges up like this. Unfortunately, despite it being a box and pan folder, I wasn't able to fit these parts in. Not only that, I'm not happy with how round those corners are. I want to have really nice sharp bends like this one I did. And that's going to make the welding far easier to do also. So then, how did I get these sharp bends? Well, let me introduce you to this simple device. It's an off-the-shelf linear bearing, as you can see. Now it's bolted to a plate, that's bolted to a plate, that's bolted to my grinder. This little strip here is got flex in it though, so I'm able to adjust the height just by putting my hand on it. Let me show you how it works. So very simply, I'm going to slide my material under the cutting disc. What I'm doing is I'm looking down the edge of my cutting disc and seeing if it's a line with the edge of these bends. Once I'm happy, I can just clamp that down. And I'll move the grinder to the next part. Just make sure that's aligned also. Clamp that down. Bring it back here. Double check alignment. I think we're all good now. So make sure you've got ear defenders, glasses and respirator on. And you can see I've continued back and forth until this part has risen upwards slightly. So essentially what that's done is created a weakened groove. And because it's slightly weaker than the rest of the metal, we can now fold it easily by hand. So I'll continue by doing the rest. There we are. So now I can just bend these by hand. And I've got nice, crisp, accurate edges
ready for welding. Now it does weaken the join here, so this technique is relative depending on the strength you need in your product. In my case, this is still going to be plenty strong enough. And for doing small parts, what we could do is weld some lugs on the table. This would give something for a part to be pushed up against before clamping down. But rather than doing that, I've simply just drawn around a part once I've got it right. And so I'll clamp this in position and then go at it. So I would say if you can't get hold of an expensive folding machine, or if your parts are quite small or very complex, then this might be a really good option. So if we start welding stainless steel directly on top of this steel workbench, then we'll end up contaminating the stainless. So what I've got is a sacrificial piece of stainless to go on top. That way, when we rub our parts against it, and as the electricity flows through, we're not going to get some of this mild steel lodged onto the stainless. Otherwise, you'll start to have little rusty bits forming. We can get away with that to a certain degree by using different methods of cleaning. We can dip this in acid, or we can do something called passivation, or sanding it out. That's always an option as well. The other thing we need to do is to clean the metal, and I've got some little alcohol wipes for that. So just cleaning every part that's going to get welded, and being alcohol, this will just evaporate, so it's not a problem. And now the satisfying part, removing the film. Here we are. Hello. Alright, so gloves on. Now for me to show you my real trick on getting some really nice tight welds. Now if I can demonstrate with these bits of steel, most people would create what they call a fillet weld, where they butt together like this. You can see this gap at the top requires a filler material, so we'd have to start dabbing in a rod like this one. Instead, what I'm doing is a bit of a lapping joint like that, and that extra material then becomes the filler material. This will make the weld 100% consistent and far easier to manage. So the moment the parts are folded together in this arrangement, I'm simply going to add a clamp to keep some tension there. To weld this thin, you must have zero gap. If anything, there should always be tension. So then, helmet down, and a nice sharp tungsten. Bring that join together, just making sure it's where I want it. And I want the tip of that tungsten needle to be about 0.5 millimeter away from the steel. And that's it, release the clamp. Fan on the weld has come on now, so it's a little bit noisy. But if I just show you the inside, you can see there's little to no discoloration. It's a very small tack, but that's exactly what we want. I should really have stainless steel clamps for this. That would stop further contamination. It'll be alright. So at this back edge, however, you'll notice it's not quite lying flat. It's raised higher than this edge here. So to fix that, I'm going to lay a piece of stainless on the top and hit it down with a hammer. That is now perfectly in line. Fit up is everything when trying to get these welds working right. Lovely. So I am making this look way easier than it is. Tacking up thin material with no filler is very difficult. I'm going to add another tack in the middle here though, and I'll show you another technique. If we simply just rest the cup down, touch exactly where we want that tack to go. I want it to go half on, half off both of these sides. Touch it, lift it ever so slightly. Go. So that is a 1 millimeter tack. And again, only the faintest discolouring on the inside. Certainly not enough to worry about. So then, we're tacked together, and that was just by very quickly tapping the trigger. If we weld it fully, we're going to discolour all of this as it gets exposed to oxygen. So to stop that from happening, we need to fill this with an inert gas. And to do that, I've just got a simple lid like this. And to secure it on, I'm using some simple paper packaging tape. Just like that. I'm careful not to let it go over the corners. But the main reason I'm using this is because it doesn't leave a sticky residue behind. Also, if our welds do get close to the tape burns, but it doesn't seem to affect the weld at all. It just kind of vaporizes and goes away, unlike a plastic tape or an aluminium tape, which will remain there. So now we're ready, we'll fill it with argon gas. I'm now switched to those pulse settings I was talking about. Let's see how we get on. So that is a little wobbly, but it is only, well, less than a millimetre. I'm trying to keep out the way of the camera, so I'm not as comfortable as I normally am. Let's see if I can improve on the other one. Let's just try that with an ND filter, see how that looks. So that was even better that time. Lovely. So next to my thumbnail, for example, let's clean this one. All done. Turn the gas off, let's reveal the inside. While it's warm, tape comes off really easily. Well, absolutely perfect. So here, for example, we've got a nice consistent weld. If you look on the inside, absolutely zero discoloration. That is exactly what I wanted. So I've just got to do that with all the others. Got 10 of these to make in all. And just using the buffing wheel, I'll take all of this colour off and give the backside a clean. Right, shall we explore aluminium and see what we can make? So many of you are familiar with my diesel heater videos. And when I say many, literally millions of you. So as a bonus, let's make a heat exchanger for this device. And for that, I've got lots of aluminium scrap. So what I have is a bit of checker plate. I'll use this dirty bit of pipe for the water cooling. For the inner pipe, I'll use this bit. I did actually buy this off Amazon, mainly because it fits these couplers. And then for the water jacket itself, I've got this old cylinder. This is an old piston from my power hammer build, which is still working fantastic, by the way. So let's start with cutting this to size. So using my jumbo marker, I've just scribbled on this plate here. And using my scribe tool, I've scored around the pipe. So you can see what I did there. And so to cut it out, I'm going to use my old bandsaw. Some of you might remember my review video on this going back years ago. This is basically a handheld bandsaw, which also has a little stand. But to use it as a vertical bandsaw, I've simply cut a little slit in and I've bolted it to it here. Those bolts are where this, cutting guide would be. Anyway, let's cut this out. So this blade's a bit too thick to cut this out in one pass. I haven't got any thinner blades, so I'm only doing it with what I've got. So we're very nearly to the line. I'm just going to show you a technique on what I would use just to sand this down using the bandsaw. And that is basically to move away from the saw edge like this as you're pushing it against it. Just takes that tiny bit off and you can get really close to the line then. There we are, just like that. So I'm going to drill a hole in the centre now. First of all, fill this last little bit with pen. This is a cheap pair of calipers, so don't do this with a good pair. But if we scribe from the outside to the inside like that, keep turning it, until eventually you can see exactly where the centre is. So I'll just centre punch that now, and I'll drill it to the diameter of the inner pipe. So I made 2 of these in the end, and I've cleaned them up using some Scotch-Brite. And so those will basically plug up top and bottom on this pipe here. So essentially this is going to be the water jacket. So I'll now need to attach some auxiliary pipes to the side of this to circulate water around it. So again, I'm going to use my black pen to kind of just put some ink on this. Real engineers will use something called engineering blue, but this is just as cheap. Hold it on top of here, and I'm going to eyeball it. Essentially I'm going to use the crook bit of my scribe here to just scribe the shape of that pipe. There we are, you can just about see it. So what I'm going to do is cut this in the bandsaw now, and then we'll file it to size. There you are, all done. So as you can see, the pipe's going to hit on an angle like that, which will make the water spiral and circulate around that inner pipe until it comes out the bottom down there. Now to create the actual holes, I'm simply going to weld this on. I'll need to cut these shorter, but then I'll basically run the drill bit through the pipe. So these will basically act as a guide for the hole drilling. Which also means I need to weld these on first so all the debris can fall out the bottom here. Alright, so I've got everything now prepped, ready for welding. I've put a white tip tungsten in the torch, that is specific for aluminium, and I've got myself some 4043 aluminium filler wire. But the problem I have, of course, is we have no idea what the parent material is. If you didn't know, there are many different grades of aluminium. Some of them like to be welded, and others really don't. But this is now a good opportunity to use the wireless foot pedal. I've put this blue protector on it because I'm often treading in chicken poo. No one wants to receive one of these with chicken poo on it. But as you may know, aluminium is an excellent conductor of heat. So when we begin welding, it's going to suck all of that heat energy away from the weld. And so to compensate, we're going to blast loads of amps to make sure we penetrate in there. The problem is, though, once the material is fully saturated with heat, you then risk melting everything apart because you've got too many amps. So you want to be able to back off those amps as you're watching the weld pool. And so the best option to control that is with a foot pedal. So coming back to the machine settings, I've got it on the maximum 200 amps. I'm never going to use 200 amps, but it's giving me the range within the foot pedal. And as I've said before, to weld aluminium, you need AC current. And I've actually set mine to 80 Hertz at 40% AC balance. Now, obviously, I don't do tons of aluminium welding, so someone might disagree with how I've set this up, but I'm quite comfortable to weld with this, so let's go ahead. We'll start by tacking the pipe onto here. Notice I've given it some distance away from this edge. That's mainly because if I welded it too close to this edge, there's a good chance I'll melt all this apart. So to give it a fighting chance, I've come back over here. Let's see if I can't mess this up. I've totally messed this up. Right, I'm going to blob some weld onto it first. There's a good chance that this material does not like to be welded. I'm pretty sure these are two different types of aluminium. Kind of working though. Let's see how we get on. Well, that wasn't great in my opinion. That started off quite ropey, and then I got a bit more confident as I went around. So now I've got a better feel. Let's see if the next one's a bit better. So I think I was rushing too much. I want to try and hold the heat there for a bit longer. So let's see if I can make this better. Owie. Still going to try blobbing a weld on first, I think. There we go. A successful tack. Oh, that really sucked, that did. I mean, it's together, but it looks awful. Let's try again on this opposite side. So quite frankly, I'm a bit embarrassed about that. That was a lot more difficult than I thought it was going to be. So I've successfully tacked on the end plates and the middle pipe here. This checker plate stuff seems to weld much nicer than these pipes do. So I'm going to attempt now to do a fusion weld, meaning no filler material. I'm just going to fuse it together. And then when it comes to do the fillet weld here, I will start using some filler wire. ND filter on, let's have a go. Oh, come on. There we go. I've got like 1 inch of good weld. The rest of the time I just kept dipping my tungsten in. All right, let's do the fillet then. Whew. Well, you know what? Without a rotary table, that was actually really difficult. I'm improving though. Just one more side to do. I don't know if I captured all that because I was wobbling this thing all over the place. Kind of improved that time round. I still kept dipping the tungsten in. And with aluminium, that's catastrophic when it happens. You can't carry on. You really do have to stop. Something that's worth mentioning is if you're going to weld a sealed container, you need to make sure that you do have vent holes, because otherwise any moisture and gases inside that cylinder will try to bubble out on your last weld. I had forgotten to drill these out, so I had to do that very quickly at the end. I really do need to practice on my aluminium welding because I've got quite a large project coming up. I'm actually going to build a sidecar for an e-bike, so much to improve. So still I'm going to do a separate video installing this because I've got lots of other modifications that I want to do for the diesel heater, including building a really big hot water tank that's really well insulated. And then any waste heat from the diesel heater, from the gasifier, from the induction forge, I can then plumb into that unit. So let's wrap this video up with a few negatives that I found on this machine, some features I haven't shown you, and a little bit of good news. So I'm being honest here, I'm actually going to miss this welder. It's very very similar both in build and function to a Master TIG by Kempe. If you don't know who Kempe are, they're like the Rolls Royce of welding machines. There's just a vast amount of options and settings to choose from, and I could have really nailed in the pulse settings for aluminium welding also. But there are a couple of flaws that I will mention. Let's say you've had a break for a while or you turn the machine off, you have to reconnect the foot pedal. It doesn't automatically reconnect. So you've got to then return on the foot pedal as well, click the connectivity button at the same time of exploring the options in here and getting the two to pair at the same time. That to me was just a bit too much of a faff. I don't want to be doing that every single time I want to weld. The options, as vast as they are a little bit all over the place. It'd be good if there was just one menu and I just keep ticking all the bits that I want included, rather than going to this place and then dropping that menu down and then going to that menu. You know, it needed to be a bit more simple in that respect. As far as the build quality goes though, it is fantastic. Looking in the inside, I mean, I don't know what all the components are, but everything looked like it was done properly. Whilst on the contrast, I've explored a lot of Chinese welders and there's always little things to watch out for. The only problem I have is with these displays, they want like a dust guard, because if you're constantly cleaning it, that screen then eventually scratches over time because you're in an atmosphere with grinding dust normally and everything. So just like a Perspex flip down shield is just adequate enough. But other than that, I can't complain other than my own skills. But listen, I didn't get to where I am by failing and giving up. The key is to make an attempt, analyze, learn from it, reattempt, progress. But I understand for a lot of people that anxiety and fear of failure is just too much. Now you might think this sounds funny, but I am just being honest with you. The reason I don't have any anxiety and no fear of failure whatsoever is because of my faith in Jesus. I was at one point a complete wreck. I couldn't get out of bed in the morning. I was very depressed. I had all sorts of anxiety from lots of different issues. I was raised by a single parent. I was bullied at school. I failed all of my subjects at school, but when I found out that Jesus is real and that he is who he said he was, and he made an absolute promise saying, "Come to me, all you who are weary and heavy laden, and you will find rest." And when I made that decision to trust and believe in him, all of my anxieties went away. Some people are not into that, don't want to hear about it, I get it, but that might just be you who needs to hear that. But until next time, get out there in the real world and forge for yourself a life worth living, and I'll see you in the next episode. Bye-bye.